Today we're going to be looking at section 5.4, which is on factoring and solving polynomial equations. And our goal is simply to do that, to factor and solve other types of polynomial equations. Now, so far, we're going to look at a quick review of some of the types of polynomials that we've tried to factor, and some of the quadratics, more specifically. And when we look at the general trinomials, we're going to say we have 2x squared minus 3x minus 20. We factor that, and remember that those first terms of each parenthesis have to multiply to give you the first term in your trinomial. The last term comes from multiplying those two. The last number in each binomial has to be the product of the last term. And then the signs come from, if this sign here is negative, then you have signs that are opposite. If that sign was positive, then you would have the same sign. We also factored perfect square trinomials. And then that would give us something in parentheses squared. The difference of two squares is going to give us something where these signs are different, otherwise everything else is the same. And taking out a common monomial factor is just being able to factor out something out of both terms or all the terms that we have. If we have a trinomial, it has to come out of all three. If we have 4 terms, it comes out of all 4 terms. So the first thing we're going to talk about now is factoring polynomials. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So that means we can take out all the factors that we can do. There's nothing else that we can do in this polynomial. Then it is factored completely. If you can continue to factor, you must do so until there's nothing else that you can do. So let's look at example 1. We want to find a common monomial factor. So the first thing we're going to look at these 3 terms. And I see, oh, they all have a y. So I'm going to factor out a y. So we take out a y. Now we're going to have y squared minus 4y minus 12. And then we have to check, can I factor that further? Well, the y, there's nothing we can do about that. That's simplified. The only other thing we could try is see, does this trinomial factor? Well, I know that has to be y and y. And the factors of 12 are either 1 and 12, 2 and 6, or 3 and 4. Well, if we look at these, 6 and 2 would be the only ones that could work, because that's going to give us to 4, or to negative 4. This is plus and minus. Does that work? Outside's give me 2y, inside's negative 6y. That gives me negative 4y. So that is factored. So now, nothing I can do with the y, nothing I can do with the y minus 6, nothing I can do with the y plus 2. So here is that number factored completely. Now let's look at b. I notice here again, they all have an x, so I can pull out an x. But they also all have a factor of 3. So I'm going to pull out a factor of 3x. That's going to give us x squared left plus 10x plus 25. Then I got to check, does that factor? And I notice by looking at this, this is a perfect square trinomial. So I know that it's going to look something like this, and it's going to be x plus 5 squared. And then the third one, c, I see that I have a g to the 5th and a g cubed, which means I can take out a g cubed from there, and I can also factor out a 5. So if we do that, we're going to take out a 5 g cubed, and that's going to give us g squared left minus, well, 80 divided by 5 is 16, so it's going to be minus 16. So now we have to check, does this factor any further? Well, I can't do anything with the 5g cubed, so that's going to go here. I can factor this further because that's the difference of squares. G squared is a perfect square, 16 is a perfect square, and it's a subtraction sign. So we're going to go g minus 4 and g plus 4. And there's nothing we can do from there, so this is in factored form. Completely factored, that's what we have. So now in the next thing we're going to look at is special factor patterns. So we're going to talk about the sum of two cubes and the difference of two cubes. The sum of two cubes says this. If we have a number cubed plus a number cubed. So I'm always going to write it that way because then we're going to use this property. A plus B and a squared minus ab plus b squared. So if we look at x cubed plus 64, this is x cubed plus 4 cubed. So now I just write it like this. Well, I'm going to write a plus b. Well, that's x plus 4. And then a squared, so you're going to square the first term, which is x squared. Multiply the two together, that's 4x. And it's going to be negative, so it's negative 4x. And then square the last term. Well, that's 4, so 4 squared is 16. And so here is your answer for that part. The sum of two cubes is going to work, the difference of two cubes is going to work exactly the same. Only now the only negative sign is going to be in between here. So again, I'm going to rewrite this y cubed minus 3 cubed, because 3 cubed is 27. So here it's going to be y minus 3 in our first parenthesis. And it's going to be y squared, multiply the two together, we get 3y, and then it's going to be plus 9. So there is what you would get with the sum of two cubes and the difference of two cubes. So let's look at example 2 to do a couple problems like that. Again, I'm always going to write these in the form a cubed plus b cubed. So I know that 27 is 3, so it's 3x cubed plus, well, 125 is 5 cubed. So we're going to start by writing a plus b. So that's 3x plus 5. And then we're going to square the first term. Well, that's 9x squared. Multiply the two together. That's 15x, and it's going to be negative. And then square the last term. That's 25. And here is your answer when it's factored. We're going to do the same thing in B. However, first we notice that I can take a 2 out and a d squared out. And I'm going to take the negative 2 out of here actually because I want that term to be positive. So negative 2d squared will give us d cubed minus 125. Well, then if we do that, it's going to be negative 2d squared. And then I'm going to rewrite this as d cubed minus 5 cubed. So now I have it in the form that it's easy to use. Negative 2d cubed, d squared, negative 2d squared is what we took out. And this is going to be d minus 5, and then d squared plus 5d plus 25. So here is our answer to B. So what I would like you to do right now is go ahead and do questions 1, 2, 3, and 4. Factor these polynomials completely. So go ahead and hit pause, and when you are finished, go ahead and hit play. And here are the answers to the guided practice questions 1 through 4. Notice in the first two, we factored out a common factor, and then we factored the trinomial in number 1. Number 2 is a difference of squares, so we factored from there. Numbers 3 and 4, we factored out, in number 3, we factored out common factor of 2b squared, and then we see that that is a sum of two cubes, so we used a sum of cubes property to simplify that. Number 4 was just a difference of cubes. And the next thing we're going to talk about is something called factoring by grouping. So far, every time that we've factored, we've had at most 3 terms. So it's been either a binomial or a trinomial. Now we're going to look at factoring when we have 4 terms. And we're going to factor by grouping terms that have common monomial factors. So most of the time, we're going to group our first two terms and our second two terms together. We're going to pull out a common factor in the first two terms, and we're going to pull out a common factor in the second two terms, and then we're going to go from there. So if we look at example 3, I'm going to take these first two terms. I have a 27t cubed and a 45t squared. Well, I see that they both have factors of 9 and that they both have factors of t squared. So I'm going to take a 9t squared out of both of them. So if I factor that out of the first term, I'm going to have 3t left. And if I factor the 9t squared out of the second one, I'm going to have a plus 5. So that's what I have left after I factor the 9t squared out of the first two. Now I'm going to factor these second two. And when we do this, the term that we get in the middle, or in parentheses, should be the same. If you factor by grouping, they will always be the same. So to make that happen, I'm going to factor out a negative 1. And if I take out a negative 1, now I have a 3t plus 5. So if we notice then that this and this are the same. So now I really have two terms here. I have the term in black, which is 9t squared times 3t plus 5 in parentheses. And I have the term negative 1 times 3t plus 5. So the black is one term, the blue is another term. So if we have that, now what we're going to do is we're going to factor out the term that they both have in common. Well, they both have a 3t plus 5 in common. So if I factor that out of the first term, I have 9t squared left. If I factor it out of the second term, I have just the minus 1 left. So that is what I would do if I factored completely. So this, or if I factored by grouping. So then the only thing we have to check after that is, can I factor it any further? Well, this first term, 3t plus 5, that's done. However, the second one, we can factor this further because this is the difference of squares. So it's going to be 3t plus 5 times, and then it's 3t minus 1 and 3t plus 1. And then this is factored completely. So that's what the factoring by grouping is. We're going to factor out some number out of the first two and then some number out of the second two to give us something in both sets that are the same. In this case, it was the 3t plus 5. So next, we're going to talk about quadratic form. And that's an expression of the form au squared plus bu plus c, where u is any expression in x. So essentially, we're going to just treat it like a quadratic equation. So when we talked about quadratics, we're going to have something x squared plus something x plus some constant. So the leading, or the highest degree, has always been double the other degree. And that's the same case here. We're trying to get them to be double. So the first thing that we're going to do is we're always going to start by factoring out anything that we can. And if we look at this, we can factor out in A, we can factor out a 10. So if I take out a 10, I'm going to have x to the 4th minus 1. And now this is the difference of squares. So I have 10, and the factors of x to the 4th would give me x squared times x squared. That's going to give me x to the 4th. And factors 1 are just 1 and 1. And we know that it has to be a plus and a minus. So we have to check, can I factor this any further? Well, the 10 I can't. The x squared plus 1, no, I can't do anything with that one because that is not a difference of squares. However, the last one is because I have that minus assigned. It's the difference of squares. So I can factor this one, x plus 1 and x minus 1. And now this is factored completely. Part B, we're going to again see what can we take out of this. So what can I take out of this? I'm going to factor out a 3, and I'm going to factor out a 3m squared. So if we take out a 3m squared, now we have m to the 10th plus, we are factoring out a 3, so I'm going to have 18 m to the 5th and plus 17. So now we have to check, does that factor any further? Well, this has to be an m to the 5th and an m to the 5th. Those two will always have the same exponent. That's the only way they can work. M to the 5th and m to the 5th. Factors of 17 are 1 and 17. Both are positive. And so it factors like that. Now we have to check, can I factor any further? Well, the 3m squared is simplified. The m to the 5th plus 1, nothing I can do with that. The m to the 5th plus 17, nothing I can do with that. So there is my solution, factored completely. What I would like you to do now is go ahead and do questions 5, 6, and 7. You're going to factor those polynomials completely. So go ahead and pause the video, and you can hit play when you are ready. So here are the answers for questions 5, 6, and 7. Again, notice number 5 had 4 terms, so we factored out an x squared out of the first 2. We did that in black. We had an x plus 7 left. And then we factored out a negative 9 out of the last 2. And again, we had the x plus 7 left. Then we took the x plus 7 out of there, and we had x squared minus 9 left for our second parenthesis. Then that can be factored further. So we had x plus 7 times x minus 3 times x plus 3. 6 was a difference of squares, and 7 was, we factored out a common monomial and then factored from there. So in example 5, we're going to do the exact same thing, but now they're asking us what are the real number solutions. Okay, so we're looking for what are the solutions to these problems. So you're going to set them equal to 0. After we have it factored, set it equal to 0, and we're going to solve all of them. So we have to start, once again, by putting these into standard form. So standard form is going to make this 2x to the 5th minus 12x cubed plus 16x equals 0. So if we look at this problem, now I can factor out a 2x. And so we're going to have x to the 4th minus 6x squared plus 8 equals 0. And so now you're going to have 2x. And we're going to factor this. So it's going to be x squared and x squared. Factors of 8 that are going to be, and they have to be same sign, so minus 4 and minus 2. So we're going to have 2x, and this factors further, x minus 2, x plus 2, and x squared minus 2 does not factor any further. So that is factored completely. So up until this point, that's where we've stopped. Now, here they're asking us what are the solutions. So what you need to do is set each one of these equal to 0. That's what our solutions are. 2x equals 0, or x minus 2 equals 0, or x plus 2 equals 0, or x squared minus 2 equals 0. So we're going to solve them all. Solve them for x. Well, this one, x equals 0. This one, x equals 2. This one, x equals negative 2. This one, we'd have x squared equals 2, which means we're going to go x equals, take the square root of both sides, plus or minus the square root of 2. So there is your solution. So if we look at problem C is the answer. We have all 5 of those solutions right there. So we're going to continue on after factoring to solve them. Remember, if it says solve, you have to tell me, or find the solutions, you have to give us what does x equal. So go ahead and pause the video, and then you can answer questions 8, 9, and 10. And hit play when you're ready. And here are the answers to question 8, 9, and 10. If you look at number 10, once you factored it down to 3x squared times 2x squared minus 9x plus 5, that last term does not factor. So if it doesn't factor, then you have to solve it one of the other ways. So in this case, we solved it using the quadratic formula. So you have three answers here. 9 plus or minus square root of 41 over 4. That's our two of our answers. And don't forget your x equals 0, because x equals 0 comes from the 3x squared that we pulled out. So if you set that equal to 0, then x would equal 0. So there are the solutions to those three problems. The last thing we're going to talk about is example 6, solving a polynomial equation. It says you are making a metal tray by cutting equal squares from each corner of a regular sheet of metal shown. What should the dimensions of each cutout square be for the volume of the tray to be 60 cubic inches? Well, we know that volume equals length times width times height. And they tell us that the volume is going to be 60 cubic inches. We know that the length is 16. However, we're cutting an x off here and an x off here, so that's going to be 16 minus 2x. And then we also know that the width is 12. However, we're cutting an x off here and an x off here, so that's going to be 12 minus 2x. And then the height obviously is going to be x, because that's the side that's folded up. So here is what we are going to be looking at. That is how we would calculate this. So now what we're going to do is we're going to multiply all these. And so I'm going to have 60 equals 192 minus 32x minus 24x. Oops, 32x. Minus 32x minus 24x plus 4x squared. And then times x. We have our x left over there. So now this is going to be 60 equals, and I'm going to distribute the x. So 192x minus, this is going to be 56 x squared plus 4x cubed. So now what we want to do is we want to put it in standard form. So we're going to set it equal to 0. So it's going to be 4x cubed minus 56x squared plus 192x minus 60. So now this is in standard form. Now typically in a problem like this, what you would do is you would factor this by grouping. The example in your book does work by factoring by grouping. This one that we have here does not. So you'd have to use another method to solve this problem. And that's actually what we're going to be looking at tomorrow. So if it doesn't factor by grouping, then we're going to have to look for another method. And since this one won't, if we factor out a 4 out of the first term, we're not going to get the same term in both sides. So this will not factor by grouping. So we're going to have to come back to this problem later and look at how this solution can be found. But this is how you'd set it up. This is how you'd multiply those numbers. You'd get it down to a spot that looks like this, and it won't factor by grouping. So we're going to have to use another method, and it's called synthetic division. So we're going to look at that later on. So again, today we talked about a variety of ways to factor. We're factoring and solving polynomial equations of many different forms, not just quadratics anymore. We're going to be looking at polynomials of many, many different forms and how to solve those. Again, we talked about factoring completely, and then once we have it factored completely, we are going to solve those problems. So your homework assignment is on page 3. So your assignment for section 5.4 is on page 356.